All right, welcome to Principles of Energy Part 2, looking at updated information on petroleum use worldwide, as well as population numbers and use of energy, because things really have changed in the last 10 years. And there's been some major differences. And so looking a little bit about energy use in the world, petroleum is still king, but natural gas is giving it a run for its money. So natural gas is another growing market. Both of them are using fossil fuels. And so when we cover our fossil fuel chapter, we will cover this in greater detail, but we will also talk a little bit about crude oil and natural gas extraction in those processes. Other places where markets have grown in the recent 10 years is within things like biomass use, which this is our reusable biofuels and such. So this is biomass, but biomass can also account for the burning of garbage. So it's a growing market, but we do burn our garbage, and that actually falls in biomass. Wind energy is another growing market that you can see here at 3.2 world over. Solar energy, which we like to think of as a super growing market, is actually just above 2% on the growing market scale, and it's right here on our little pie chart. Hydropower, which big hydropower construction hasn't been occurring much anymore, but it's still there, and there's a lot of micro hydropower going on, and we'll talk a little bit about that. We'll talk about oceanic power and things like that along those lines. Nuclear electric power was once a growing market, and now it's a reducing market as we start to move away from nuclear energy. And coal, which has been on decline and just continues to decline world over. So comparing energy consumption with world population. One of the things that we want to think about as a person, but also as the world and our policy moving forward and what we can expect for the future, is how small the US population is and how big our energy consumption is. So we get a really big piece of the world's energy supply, even though we do not have the biggest piece of people in the world. So here we go, world population. You can see which countries have the largest populations the world over and how gargantuan it is versus others. And once again, like I said, I always cite my sources. So here you go. You can see where I got my information from. And then we can look at per capita electricity consumption. So now an interesting thing has happened in the last 10 years. We actually fell to second or third in electricity consumption, and electricity consumption is actually greater in places like Canada now in the world, that's kind of bodes well for us. It means that we might be on a good path in the US and we can continue to go there. It might also say something about global climate change and the need for things like temperature control in parts of the United States that require temperature control and now do not. So there's a lot of ways to look into it. And if we start to pick it apart, it gets very complicated very fast. But feel free to jump that rabbit hole because it can be really interesting when you do. So looking into it, you basically can see here down below, we have energy consumption in kilowatt hours down below. And then they have a color coding on who gets to use how much energy. And one of the things that you might find interesting is that some of the biggest populations are in China and India, and you can see how little power they use, even though they hold almost 40% of the world's population over here. So there's a big difference and in how much consumption of energy is being utilized the world over. Global energy consumption based on fraction scales, so fuel types. And then one of the things that I want to point out, because I like to go over units, intro chapter is a good place to do this, is gigatons of oil equivalent. So when you see this GTO, when you see these equations written in a GTO, what they're talking about is measuring it based on oil. As we established before, petroleum is still king, and natural gas is a good comparative since it's also derived from fossil fuels. So equating everything to gigaton of oil, comparing it to a gigaton of oil as a unit is still an easy way for people within the industry to think about it. And so you can see all fuel types down below based on a percentage on that unit, and you can see what they're used for in their different sets based on global energy consumption within these fractions. Now, the renewable part here, because I want you to be able to understand a graphic, I should be able to give you this graphic and you should be able to pick it apart and extract information. So the renewable energy down here that says 12.6%, that 12.6% has now been blown up into a 100% marker, and they're showing you how that energy is used the world over as a renewable. And you can see hydroelectric is the biggest one. And then you have geothermal and biomass, wind, solar, and biofuels as your breakdown. This brings me to being able to do some simple equations and mathematics. Another piece of this course, we will ask you to actually work through simple equations and some mathematics and thinking through how to answer those problems so that you yourself can derive your own answers on things. When it is equation based, I will actually be providing equations for you. My expectation is you will know which equation to use when, but you do not need to memorize any type of mathematical equations. With that said, the question that's being asked is U.S. oil reserves are estimated at 29 billion barrels. So the unit is billion barrels. We currently produce about 6 million barrels per day. How long will these reserves last at this production rate? So doing the math, I do not need an equation for this because I know very simple information. I know that the reserve is 29 billion barrels. So I can put all my zeros on that. I know that my production rate is 6 million barrels per day. So then I need to first find how many barrels we produce over the course of a year. And so I can take the yearly production rate, and I'm going to put down my production rate based on day and times it by a year. When I do this part of the math, the days cross out. So I'm going to cross out day and day, and I'm going to get billion barrels per year in my units. And when I times it up, this is the answer that I get, nice and clean. And so then to finally answer the question, now that I know how many I have per year, I can then take the reserve, divide it by how many barrels I use every year. Billion barrels and billion barrels will cross out. So those units will cross out and I will be left with years. So at current production rates, based on this question, I can expect 13.2 years if I continue to produce oil at the rate with which is currently presented in the problem, which means that there's a reason to reduce the amount of rate because we don't have enough to continue our current production level so that we can stay at that only 21% imported and the rest is kept in-house. So there you go. A question like this will be presented in your short answer homework for this class session. So ending out the class, we're going to just quickly touch on the fact that we have a history of oil dependence, and this is the world over. It's not just in the US, it's the world over. Nations that are up and coming and currently developing have been able to kind of come out of this and pivot to other resources, but the United States itself is incredibly dependent. And so just a couple little facts to touch on. In 1763, steam engines was invented, and this was first powered by biomass. So the first form of diesel that we would use was actually a diesel produced by plant. And then we found it easier and cheaper to pull it out of the ground as diesel. And we pivoted away from producing it out of biomass into the form of pulling it out of the ground to get it. Because coal was very common in the United States, we moved to coal. So the steam engines were then run by coal. And then finally, when oil refining processes became very easy to run in 1854, we moved to that, and basically oil took over because it was cleaner and easier to extract. In 1859, the US established its first modern oil well in mid-Pennsylvania. And in 1870, the combustion engine was invented, and this basically was the course setter for the future of our energy production in this country, as well as our entire industrial complex that came about in the turn of the century, the turn of the 1900s. As far as U.S. oil production comparisons, this is a Hubbard curve. This is a Hubbard curve, and it just shows the dashed line of what we can expect in anything. There is a peak point, and then everything kind of tapers off. And so this is the standard Hubbard curve that we can follow, and we can just see what the actual data has had happen to it. And so you can see that there's been ups and downs on oil production, but it is tapering off and becoming less common. With that said, in a 55-gallon drum of crude oil, you can actually break it down, because we process crude oil to make a ton of other stuff. And this lovely little graphic here, which is so interesting, within the gallon drum, shows what percentage of that raw oil becomes what. And so 19.4 gallons becomes gasoline. You have your diesel and heating oils, jet fuel, heavy fuel, propane, asphalt and road oil, petroleum feedstock, and then all the weird others that we use petroleum for. Moving forward, natural gas production is also kind of hitting a stride, but and then started tapering off in the 1970s. After the 1970s, it started tapering off, but it's back to hitting its stride again. The plants to burn natural gas are pretty easy to construct, and there's been some changes in technology. And these are things I'll touch on more when we hit our fossil fuel module within this course. But fossil fuel is actually on the rise again in the US, as well as Canada and a couple other nations around the world. It kind of depends on what type of energy resources you have. Will decide whether or not it's on the rise in your country. And then this graphic shows us a little bit about oil pricing. So dollars per barrel and where it's going, and then the various economic crises. It's a little outdated as a graphic, but it gives us a nice touch on the history and what's occurring and how volatile the petroleum market can be, and why consistency within an energy system is not just good for our pocketbooks, it's also really good for the stability and growth of a society. The more stable an energy source is, the easier it is for a society to grow, move forward, and head towards a cleaner, greener, brighter future for everyone. So helps with equality as well. On these notes, you basically are getting an overview of the entire module 1, and I think that touches on everything. So hopefully this will be a 2-part video, which is nice. And I will see you back again on module 2. Bye.